In this presentation, what you should expect is I will brief you about some of the concepts and why technology and the pattern like a service mesh came to be, and why it is becoming more and more important and more widely adopted across multiple people, multiple organizations, multiple engineers. And we will play around with some demo. I will be playing, you'll be watching, but I'm expecting some of the questions. I'm expecting some of the interactions from you, because I doing this to teach you something, and I also interesting to learn what you also want to know about this. So with this, let's jump right into a few slides. Particularly since I will be talking a little bit about microservices, and microservices will be kind of conversation started as architecture pattern that drives some of the innovations around how we distribute software and how we deploy software and how we operate software. And I also would be interested if you hear specifically to learn about the service mesh as a concept, or specifically to learn about Kuma, which is a CNCF sandbox project where we at Conk actively contributing to. Plus, we built some enterprise solution based on this Kuma. It's called Conk Mesh. And if you have experience with some other service meshes, all right? So with this, usually when I talk about some of the new technology, some of the innovations, some of the things that we are doing in 2022, some people can say, oh, we start doing so many things and it's becoming like a super complex, and we're doing this. We did this much better in the past. Everything was much easier. Grass was much more greener. Our trees were much taller and things like that. So right now we have all this nonsense with distributed systems, clouds, cloud native, Kubernetes, all things, right? Specifically, if I would like to address some of the things that were in the past and the things that we were considering as simpler things, well, there's a lot of complexity was hidden from us, so we were relying on some of the platforms that will deliver this. And this sentiment about relying on the platform to deliver certain piece of functionality, just like keep it in the back of your mind, because I'm going to be returning to this. So here's a typical scenario of enterprise application. This is something that I was building in the past, and many of you who join us and who've been in the industry for a while probably build something like this. You have a traditional 3-tier application where is a business logic separated from the data access layer, and you have a database that will be deployed on a separate server because you don't want to, your application server will be running on the same server. Usually it's different teams will be operating this database, and getting the permissions, getting the access to the system will require some of the setup. And some of the pieces of infrastructure that you used in the past might be you will be relying on some of the piece of infrastructure. For example, as I said, the database can be managed by some other technologies, where other technologists who will be configuring something for you, and you will be relying on some of the infrastructure layers like a discovery service that's available, for example, in Java EE world through GNDI. But this is complex things, your code running all together, and you cannot efficiently grow. So those things lead you to refactoring to microservices. And this is what we've been talking about, how the architecture of the past will be evolving and how the technology like a service mesh will help you to support. My name is Viktor Gamov. I work as a developer advocate here with Conk, and one of my responsibilities is do some of the educational tasks to teach you and show you and get you excited about the particular piece of technology. I want to show you what is possible so you will understand what you can do with this technology. So traditionally, if we're talking about microservices world, we start talking about microservices world and the containers world somewhere around the same time when some of the big tech companies, web scale companies, start building and start talking about microservices and how they would able to scale their businesses by implementing this pattern. At the same time, those companies also talking about evolution on the way how we package software. We're talking about containers, we're talking about APIs, and we're talking about the orchestration and all this kind of thing. So let's get back to the previous picture. Let's get back to this picture and see where is this, former simplicity, things that we thought would be, easier. Now, the concept of let me actually show you. So the concept of the system where you kind of like depend on some other system that deployed across network can happen, for example, over here, right? Access to database will be usually, if it's not something non-essential or non-important, your database will be deployed somewhere and there will be special trained people who can provide you access there. Maybe those people even provide you will help you to set up the schema for these databases. So this is here, we already have some network. So this is some network already here. So it is not that simple like application. We have one tier of application that runs in one application server, another tier will be running in some externally here. Plus, in front of here, on this picture, I might not have it, but usually you have something like load balancer in front of this application that allows you to do routing or maybe some additional features. So things that we were thinking, the monolithical applications, they're actually not that simple as distributed microservices. Though there's one difference, and I will talk about this difference in a few more slides. And the difference is between how we place the business logic and how we interacting with some application components, right? Once again, when we get back to the idea of bringing this monolithical system and how this monolithic system will operate and interact with the external system, usually we're talking about network. So, and that network is something that we think it should exist and it should be reliable, it should be secure, and we as application developers don't want to think about this. It's someone else's job to make sure that something needs to be handled by some other people. However, there are some fallacies about this statement, like every developer needs to think about the network. The next thing is that we might have a situation where the things will change to the point where your services needs to communicate to each other. You, as a microservices developer or like any services developer, or you're trying to break down this monolithic system to have a much better velocity on updating features. Now you switching to CPU-based computation into something that's like more like a network-based computation. Instead of like calling some of the local code, we're calling for network. So in the past, we were dealing with, inside one process, we were having a built-in process isolation. We will have things around your operating system or your kernel provides you the ways how you can restrict one process with accessing another one. But with these things that were given to you within the monolithic system, there's also some of the problems coming from. So you have all this isolation and your code is collocated. You don't need to think about the network. However, it would be much difficult to evolve this because every time you need to update new code, and in order to run this new version of the code, you need to redeploy full application. And over the time, you, as a good developer, you will try to decouple this, maybe by modules, maybe by like decoupling some of the pieces of functionality in different packages, but it might lead to things around duplication of the code. Now, and we're moving into, with microservices, we're moving into CPU-based, the network-based computation. Now, instead of calling the packages inside our call, we're calling the APIs. And things about the network and the fallacies about the network or misconceptions about the network. People thinking that's, even when the people thinking that someone has a problem, it's actually your problem. There's many things might have happened. How they make the network secure, how make network reliable, how provide the logging, how provide tracing. All these things needs to be taken care of, either for you as a developer or for some of the infrastructure people. Usually developers are want to make sure that the application that they built would be successfully running in production. So they're putting some of the pieces of functionality inside their application. For example, logging. Like we're putting different libraries and we ship these logs into a central logging facility, and where we can see this application writes the logs here. Same thing with things around the tracing, because observability has become a very important component of application development process and application delivery process. So tracing, dealing with the things like security and encryption, you can build in your application. It's not a problem. So when we were back in the monolithical world, we will take care of that, the connection. So inside our application, we will build some things around, like connection pools, or some of the library that will be providing you ways how you can retry, or some of the graceful backoffs in case of system will be failing. We start implementing patterns around like circuit breaker patterns in our application. We start implementing things with the back pressure. Some of the libraries did this successfully, but only certain things you can do within the library or within this particular language. So for example, I came from the Java background, and I know like a ton of different libraries can help me to solve all these problems with the connection pools and with the logging and all this kind of stuff. But this problem might become more complex if you are following a kind of like a pattern or kind of like idea where you're trying to diversify and create more opportunities for developers in the different languages. So one library might have certain functionality. Java has like everything, and some other languages might not have it. Like maybe certain patterns of dealing with database are not widely adopted in this particular like language or or in particular like a framework and things like that. And how you would interact with the other code that's written by other developers, you need to re-implement the same stack or force them to use one piece of technology. Some engineers might find this boring. So let's see how we can fix this in future. So now with the refactoring, now we need to over the time how we can go decouple and distribute the software, and now it becomes like more and more important, since okay, we start decoupling these microservices, we start bringing all these pieces of functionalities close to applications. This code that will be interacting with other systems, it will be growing. So that's the problem. And if we're not trying to solve this problem earlier, to implement some of the patterns that will scale, that it might be a problem in the near future. So remember that load balancer thing that I put in front of my architecture, and historically those load balancers or proxy servers, like reverse proxy servers, might solve some of the problems from perspective of infrastructure. If you remember, if you need to implement some corporate-based security layer for your application, you usually put something on top of this load balancer. There would be a SSO page that will be, driving users to a single sign-on where some external security system will be managed user sign-ins, and you as application developer don't need to deal with this. Also, those things that we discussed that will be dealing with the connection and connectivity were previously handled either from library or from the infrastructure. If you're running this in a big application server like, I don't know, JBoss or WebSphere, some of the things like a centralized login facility or connection pooling and resilient communication with databases, they were handled by those pieces of architecture. So there was someone who will be providing this opportunity for this, providing these pieces of functionality for you, right? There's a few approaches how this can be solved. One of the approaches solve this with the shipping this as a part of some sort of library and distribute this library across multiple developers. But there's interesting idea is to not only ship this as a part of library that will be language specific, but what about we can ship this piece of functionality as a component, binary component, that will be running together with your services, and it will handle some of the low-level communication. Again, remember, infrastructure, we're building code, we're not building infrastructure. So they're taking same idea, so extracting this piece of functionality, piece of commonly used functionality, including logging, tracing, the capturing of some of the important security information, maybe TLS termination. Handle this outside of application process. Handles this inside some of the piece of infrastructure that will be available for your application developer, and your application will be communicating to this system through localhost locally. So there would be it's very hard to imagine some of the problems that happened locally, and rest of these hard task would be handled by this proxy. And when we imagine how we can put this binary proxy alongside with our application, now we can add as many services as we want. And if we build them ourselves, we can use whatever programming language we want. Those services would be communicated to each other through this proxy communication. So those small applications, small proxies, and they will be communicating. Now, this communication can be configured, but how we can configure those communications? So that's the very important task that we need to talk about in a second. So we figured out that we're extracting pieces of dealing with networks, pieces for dealing with communication and some other things as a separate binary process. Let's think about what we're going to be doing this. So before we jump into configuration, I want to bring the one important point that I started on the very early when I was talking about containers. In the past, we were ship our software in whatever native package was available in the Java world. There was wars or was ERs. You can put this in a zip file. You can put this whatever, or RPMs, Debian. So essentially, the packages that allow you to bring the software from the place where the software was built, CI system, into the place where it will be executed. Like I said, RPM or deb was one of the solutions. Now, since here we can introduce some of the ways how we can package this, like the containers would be more or less natural approach how to deal with the software distribution, but there's still the cases where those things might not. So you want to run this in the bare metal. It's fine. You don't need to run this container. You still can run this as a RPM, and the same pattern of communicating between the services needs to be supported here. So in the world of containers, you can have another container that will be running in the same network with your application that runs in the container. In the world of the bare metal and the host-based system, it will be just another process where your application will be talking through the network. And local communication is important because we need to modify latency between the proxy and the servers, and it needs to be minimal. And our proxy needs to be running as close as possible to our services. So for our service, this communication would be local. In case of virtual machine, it would want the proxy run alongside the service, and in case of container, it would be what we call like a sidecar container, or maybe even built in within the same container of your application, and external communication will be handled through this proxy server. And that's the powerful idea that allows to unify. And this is the idea also you need to keep in mind when I will be talking about universal, the proxy for your application, or universal proxy server that's running around, like close to your application, regardless if it's a containerized workload or it's a hardware workload. Now, so we agreed, hopefully you agreed. I'm not fully follow the chat. Hopefully there's some cool discussions and some questions. I will get back to questions in a quick second. So there's a very interesting and very good question that I want to address this right now, because this question will definitely appear in my demo. Does Service Mesh eliminate the need for ingress API, gateway API, or does it work hand to hand? This is a very good question, and I promise you that was not prearranged. So the answer is the yes. You can run the Service Mesh without dedicated ingress, because Service Mesh like Kuma has built-in capabilities for exposing services to outside world. In my demo, though, I will be using Kong as my ingress/gateway that runs together and runs within Service Mesh, and this Kong gateway thing also will be able to be part of the network. So answer here, yes and yes. You can run without dedicated gateway, or you can run with without it. Okay, so I will return to another question from anonymous attendee. When I will finish talking about the importance of another component in the Service Mesh. So Service Mesh actually contains few things. So it contains actual workers, proxy servers, or how we call it, the data planes that will be running alongside with your application process. Now, with the complexity growth in terms of how services will be growing services in our architecture, we will be able we need to solve the problem of distributing of configuration. So historically, configuration management also was the part of application delivery pipeline. So the configuration management was something that many systems, many software products were trying to solve, how to deliver particular configuration this. So instead of relying on some of the tools that provide these pieces of communication, like essentially go and use some generic tools to distribute communication for those particular, the data planes, this proxy processes, we can actually do a little bit better, because we want to have our architecture scalable and also flexible. We want to ability to configure this not only when we doing rollouts, but maybe we need to change dynamically this traffic, and those proxies need to support dynamic communication, dynamic configuration. With this, there should be some centralized configuration service. So we can push this configuration into configuration service. And after that, this external configuration service will be responsible for making sure that this configuration will be available for all our proxy servers. That hypothetical place would be the source of truth for our configuration. And this is where we can communicate and attach all our configuration management, from some management of centralized configuration management for decentralized application, if it makes sense, right? just like that, and we basically just invented a service mesh. So essentially, service mesh includes one important component that will be running everything for us. That's the control plane. That's the actually know-how of the service mesh. That's the most important component that will be dealing with configuration. So writing the proxy is I'm not saying it's easy, but writing a proxy, it's possible because there's a plenty of different technologies available for developing those proxy, and there's some technologies that purposely built for solving this particular task with the dynamic configuration management and a very rich set of tools that allows to do all this traffic management. So control plane provides the centralized place for decentralized workloads, and these communications, these configurations will be shipped into data planes. And data planes smart enough to operate this in case of there would be network partitioning and they don't have new data from configuration server. So they can still have a stale data, but they will not be very closely coupled with the control plane system, right? And it turns out this architecture scales very well because there is no need for those control plane to be always up. It will be, eventually it needs to be up, but we want to operate our systems without, in case of the things will go south. Many of us, many of you hopefully heard about service mesh in the context of microservices and containers, but any architecture can be run this. And also, you will be surprised, but also monolithical architecture also can benefit from running this inside the service mesh, because there's some of the benefits that the service mesh provides for this type of workloads. Now, this pattern is also applicable not within one data center, but also applicable for traffic that goes beyond one data center. So it can be, we can have a global control plane that will controlling one smaller mesh or bigger mesh, or whatever mesh in the different data centers, and this global control plane can be responsible for shipping those configurations. So that's very powerful. There's many different implementations that are available of the service mesh pattern. So we're gonna be focusing for the next I don't know, 10-15 minutes. We're gonna be focusing some of the things that we have available for you via Kuma. And Kuma, it is an open source project. It's a CNCF sandbox project. You can go and check this out in kuma.io. Kuma uses Kuma. It is a control plane for service mesh, control plane for this Envoy-based proxy. So data plane will be used. We're going to be using this open source project called Envoy. That Envoy would be responsible for handling this traffic and will configuring the communication of our sidecars or our data planes, and Kuma will providing configurations. Now, that's it from my slides. So it's time for me to look some of the questions. Sean is asking, what are some options for integrating Windows hosted apps and APIs into service mesh? A very good question. A very good question, Sean. So Kuma actually has support for Windows based, but it is actually part of Kong Mesh. So as I said, Kong Mesh is enterprise version of enterprise offering of Kuma, and it has a Windows-based Windows support. So Kuma has Windows-based support. The Kong Mesh has Windows-based support. So hopefully it makes sense. Okay, so I was promised to answer this anonymous attendee question. Is service mesh solving distributed application complexity or network complexity, i.e. it would seem to reduce the boilerplate coding and application rather than provide distributed API model for provider-consumer model. Your thoughts on there, where it best fits? So I started my conversation with bringing the old technologies like application server technology. Application server technology provided pieces of infrastructure for developers to operate on. It provided the ways how you can discover some other services. There was a kind of naming and directory service, GNDI, for example, that provided ways for me not to require to implement this myself. I could do this myself. I can have database connection and I will be using my database as my everything. I would put some of the discovery there, some other applications will join and register there, so I will go and find this information in this database and things like that. But I was not doing this because I was operating against particular APIs that were available for me to operate on. So I always, even I was using monolithic applications, I was relying on some infrastructure. So service mesh, it's another piece of infrastructure that provides you the ways how you can build reliable connectivity for your application without implementing this and built into the application itself. So idea of the microservices was kind of like a micro. Your service needs to be serving only on particular tasks. Those services needs to be focusing on solving business tasks, but rather than not solving some of the infrastructure bits. Hope it makes sense. So we are solving a application complexity. We're solving a kind of like a operational blindness with service mesh because of the built-in observability tools. And we're serving most important thing that we always forgetting is the concerns around security and how the traffic would be encrypted and how we can manage access to the certain components of the system. So let me jump into the demo and we will see what is going on here. So in order to demonstrate this and in order to explain some of the concept that I would like to show and where the service mesh actually shine. So first of all, I will be using a Kubernetes version. So in this case, I will be focusing on containers, though Kuma and Conk mesh as universal mesh, you can span it across multiple different environments. One environment can be Kubernetes cluster. Another environment can be your VMs. Another environment can be your bare metal in your data center. Second thing is that you don't have to have a source code of your application in order to enable this in order to enable service mesh. So in this particular case, as example, I took some of the demos that is available for Google Cloud Platform users. That's why it's called like a microservices demo from Google Cloud Platform. Those are essentially implementation of online store. There's a few services. More importantly, those services are written in the different languages, and pieces of functionality that this services expose, they expose through the gRPC API, and Kuma will support this. So in my Kubernetes cluster, I already have a. If I would just run Kuma control. Kuma control, it is a command line tool that allows me to quickly interact with my service mesh, and it has a server-side component that is our control plane and our like kind of like application-facing component. So in this case, if I will show you in my namespace where I'm running my applications, I call it boutique because this is how Google applications called it. And there's different services running inside this boutique. And if I will show you, the namespace and one of the labels of this. One of the annotations that we have in this namespace, it says sidecar injection enable. What does it mean? So since we have this control plane running inside Kubernetes, we can use some of the Kubernetes capabilities in order to improve the way how we can configure our services and how the services will connect to our control plane. So in the Kubernetes, there's the concept of the sidecar, where we have one application container, and this application container will be placed together with this sidecar container, and they will be part of one pod. So for example, there is a, say, email service. Email service has this server container that will be sending emails, and it has two more containers. One is the Kuma sidecar that will be run underneath, that would be running an instance of Envoy proxy, and this sidecar will be configured to connect to control plane. So if I will go in my service mesh UI, essentially, if you go to this UI, right now it's exposed through the local host. I'm using port forwarding to expose this, but this UI is available for everyone. It's a part of Kuma, and in Kong Mesh, it's just like a branded version. So what I can see here is that when I will go and check all these data planes, I will see there is a 17 data plane proxies. Some of these data plane proxies will be related to my application. Some of them would be related to services like Prometheus and Grafana. I already have this in my system. In order to implement those, my service mesh Kuma has special commands. So if I run this Kuma control, I can do things like install. And I can install multiple different components. In order to install control plane, I can run this install control plane command. I already ran this before we started. Also, I can install all technologies that will be corresponded to my use case of the capturing the logs and capturing some of the traces, capturing metrics from the system. I can install logging, metrics, and tracings. All these things, things that will be available in my demo application. And in my demo application, I also have a Grafana is up and running. There are, so it's not up and running apparently. So because probably port forwarding died. So I'm going into metrics. I can say localhost. Okay, we're going into port 3000. I love you, 3000. And getting back to Grafana. When I configured Grafana through the Kuma control, also it installs all dashboards, and specifically dashboards related to Kuma. So in this case, it is a metrics from control plane. Control plane is, again, it's our configuration service. That's the most important service that will be sending configuration to other components. Now, the next thing that I would be interested in see what is actually happening into my application. So I want to see the service map. Service map is not populated. Why it is not populated? It is not populated because I didn't enable some of the policies, that the traffic policies, to capture those. In order to these things will be working, I will need to do a couple things. There's different policies, but specifically in order to start capturing all this useful data, I need to configure traffic traces, and I configure traffic logs. So my service mesh will start capturing this information from my applications via sending this configuration to my data plane proxies. The way how it looks like, since we're doing this in Kubernetes world, Kuma provides some of the custom resource definitions for certain components. And for all these policies, we can have tracing logs and some of the traffic traces. Also, I need to specify where those metrics will go. In this particular case, I will be using Prometheus, and where the traces will go, and they will go to Jaeger. For now, like my mTLS will be mTLS config will be commented out. I will enable this in a few more seconds. So now if I will just apply this, and now I should be able to see, now I have a traffic logs. Where is the traffic logs? Now I have all the traffic that happens between all the services. If I can see here in my configuration, between services, from any service to any service, we will be capturing this information. Same thing with traces. We want to collect all these the communication that happens between those systems and put this information into our collector. So let's take a look if it changed anything for our metrics. So let me run the quickly refresh. I will go and click around the system. That's the system. I didn't show you in the very beginning, but you can actually go there right now and you can hit shop.conk mesh conk. You can do things like this. If you go into this URL today, you will be able to click around and we can generate some traffic here. We can place some orders. We can do continue shopping. And with this, let's see. I'm going into my, let's see, my data sources are up and running. So that's my Kuma. Let's see, it's up and running. So data sources up and running. So let's explore those. We're going into, where is it? Explore, yeah. And when I go to my Kuma and the type of mesh graph, and when I run this query, I should be able to see in this. I should be able to see all this traffic. Let's see, something is not right on my side of things. Let's see, logs are here. My traces here. So I already have this configured. Let's see what other things are not configured here. So yeah, zero trust security is not configured, but observability and metrics, everything is configured. Let's see if it requires some additional time. That's interesting. Default mesh with the no zones, run query. Yeah, so with this, so this is how the topology of my application is looking. So the traffic, like all the traffic within the services, will be handled by Kuma, because all these containers with application will be running data planes, and all this communication to this application will be handled through these data planes. All this information also will be collected and shipped back to places like Prometheus, places like Grafana to visualize it. Now, one thing is not mentioned here. One thing is not here is that we have this like a front-end system, but if we will look in our network, say we're gonna go shop here, and we can check the headers here. That particular thing is going through the conk. It's a conk putting some headers. We know that it runs in front of conk, but the conk is not there. We don't see it here because conk was not a part of service mesh. So we will add this as well. So right now there's no gateways, and the idea of Kuma, an idea of conk mesh, is provide you with very developer friendly, and user experience and developer experience was important. So that's why this UI has like different wizards that allow you to enable certain communications. And because I wasn't sure how many people will show up, I wanted to show you more or less realistic traffic. So in a time where I'm not clicking around, and the traffic will be generated by my generator. So that's my the system that's called Locust that will be generating traffic for my service mesh. I'm hitting this this host with shops conk mesh, and I'm seeing that's like it's pretty good responses. We have zero failures and all this kind of stuff, right? So everything is good, everything nice. Now, next thing that I want to enable TLS between the systems. So I want to immediately like encrypt the traffic between these systems. So what I will do here now, I will just go ahead and enable. And these things when we'll see here, specifically in we see that mTLS is not enabled, and TLS report, it doesn't have anything enabled. It sees all the services, but TLS is not enabled. So let's fix that. We will enable mTLS between all the services within the mesh. We have a built-in certificate authority, but Kong mesh supports some external certificate authority. So when I go ahead here and I just click, so we configured mesh. Just go ahead and quickly refresh my screen. And now, all of a sudden, I start seeing that with just like one configuration that we sent in our control plane, all these data planes now provisioned with the certificates, and now all services talking to each other through TLS. Now, let's see if our application is still working. What is happening right now? We start seeing the failure rate is increasing. So meaning that we broke something maybe, right? And the reason why we start getting these errors, that our gateway cannot access to those services, because we just closed our service mesh. We enable mTLS between all the services, but our gateway was not the part of this mTLS game, so we need to fix that. So we need to enable or make this our proxy server, our Kong proxy part of our service mesh. So you can do this through from the wizard like this. We can say in the service mesh default, we can have namespace. This is where we have this is where I'm running my Kong gateway, and it gives me command that I just need to go ahead and run in my terminal. So what it will do, it also put in my Kong namespace, it's put the sidecar injection enabled. And after that, I will just roll all these the Kong-related pods, and will bring my Kong gateway that was running in a separate namespace into my service mesh, and also enable mTLS between my gateway and my services that will be running inside my service mesh. So if I will get back here, I already see 19 services, more services than expecting, and some of the services still offline. And the reason for that is just like because it's just a rolling Kong service. Now, and when I switch to UI to check the data planes, I see that now I have a gateway here that is also part of my network. And let's see if my application are back online. Now my application back online. What I see here, my error rates went down, and my users are also back here. Like everyone is happy right now. And when I will refresh my service map, I will be able to see now my Kong gateway proxy also part of my service map. Since I also put the data plane next to my Kong process, so now I also immediately start capturing all this observability data that comes all the way from when the user clicked into the system up to the point where all these services will be getting this data. So I think it's time to answer some of the important questions. And one most important question is, what terminal is Viktor using? You know what? I get this a lot. So it is just a ZSH terminal. You can find my configuration here in the files. If you want to learn more about this stuff in my terminal, you should join my Kong Builders live stream that happens every Wednesday, every 2 weeks. We need to return to a general cadence of this talk. All right. Is tracing done through auto instrumentation? Is there any way to extend or customize instrumentation? So instrumentation happened on the data plane level. So data planes will handle all these informations. I'm not sure what kind of customization you're looking here. But this is what we get from Envoy. So Envoy is a system that was designed to have observability observability in mind. Let's see if our traffic, our traffic back to normal. And now, first of all, we do have like everything like end-to-end encrypted, and my application does nothing to enable this. So first of all, I'm getting this HTTPS and mTLS termination on the conch gateway level, and the way how the conch integrates with the components like a cert manager, and we'll be retrieving the certificates from let me show you. Certificate is valid because it was issued by Let's Encrypt, and conch integrates with this nicely. Next thing is that my conch now part of the service mesh, and all this communication inside my service mesh also encrypted and using the TLS, and all this kind of jazz is happening for you. But still, even though it's encrypted, I still have a look in observability into component. So some other things that we can do here. So let's explore some dashboards that are available for you to play around. So first of all, we do have information about data planes. We can see what particular data plane is serving something. So let's take a look on this one from, it's a conch. Probably we don't have information for the last 5 minutes. Maybe we have it here. Let's see, no data. So the traffic permissions, blah, blah, blah. So still a connection to control plane. It's all nice. Let's see, we have email service. Also active connection too, meaning that there's a two communication between two systems. I can use the similar approach for traffic permissions, the one that traffic routes, and right now, like, all traffic is enabled for all components, but I can also turn this into kind of like a more restricted environment where I can put the explicit traffic permissions between the services. Now, when I already know this from my service map that I have available here. Discard this panel. Let's see what else we can have here. So we can also see metrics from the service to service communication. For example, front end and checkout service, and we see how the traffic goes and what's the latency between our front end, the web app that will be showing all these nice items, to the point where we're getting all these responses, and all these things we can get again for free because it's a built-in in a mesh. So let me quickly take a look for login. What kind of information does the proxy publish by default? Is it configurable? So let's take a look at login. With where's the Explorer? So let's take a look on first of all Jaeger, and we can find trace ID from, say, we want to see trace ID from front end to service, checkout service, and let's see. So we can have all the tracing information. We start capturing tracing information from one service to another, and we will be able to see how those two services, what is happening in these two services when we need to investigate something. So we will be able to see, say, for example, that my front end call to checkout service, and I will be able to retrieve the logs from this particular trace for this particular moment of time. So we will be able to figure out where the problem is happening. That's the question appeared here. Now, so in terms of configuration, you can always take a look in, again, once you run the control plane, you will get access to this UI, and from traffic logs, you will be able to read documentation, because now it's hitting Kuma. We need to 6.1, I guess, or 6.0, yeah. And all this information about what kind of logging backends, what kind of customization available. I did the last year presentation at the Kong Summit where we talk about how to ship this data, log data to Elastic, and how you can configure the Elastic to read this data, and using their tooling to explore what is going on there and how the stuff is, what is happening in the system. Maybe there's some like a machine learning thing that will be analyzing your logs. But essentially, information about customization you can find here. For tracing, I assume we used as the standard trace headers and that application should propagate. So yeah, that's correct. We're using the standard whatever, the Jaeger and other traces. So those traces actually can work together if we configure tracing a plugin for Kong. Probably I need to do this for the next time. So enable the tracing plugin on the Kong, and this trace will be propagated all the way from the browser to the particular service, and we will be able to capture this. That was the answer. So we are almost at time. So most important thing for this conversation, go to kuma.io to learn a little bit more about service mesh. You can always find all these demos that I showed in this repository called demo scene, and specifically gate for mesh, and has a demo. Kuma has its own built-in. If you go to kuma.io, if you go to Kuma, and you can find the you can install this, you can deploy this. There's even like you can there's like built-in demo app that you can run from the very beginning. When you start with the Kuma, it actually has a nice the wizard that you will understand all possible ways how you can configure the service mesh and what is available and what is possible to do here. So play around with this. Follow me on Twitter. Ask some questions there. Go to our YouTube channel and sign up, subscribe for the channel and enable notifications. We're doing some live shows soonish. I need to get back to this like a regular cadence. But with this, as always, my name is Viktor Gamov, and I wish you to have a very nice day.